So it's Intro to Digital Video Synthesis with Hydra. All right. In the meantime, welcome everyone. This is the Algo Club. It's part of a collaboration exhibition that we're doing with the Cell Theater and Flex Factory. The idea is to build a temporary club space and have a party in it. But we're also doing some community building, having some workshops. Tonight there's an Algo Rave, which is where we will be live coding music as well as live coding visuals to go with that music. We have some installations that are getting set up back here. Highly recommend you come back later and everything will be set up and we can have a little bit of a party. But for today, we're here to learn. So we can probably start getting into it. Are we good on the live stream? Cool. Okay. Yeah, so a little background on kind of what digital video synthesis is. There are these things called video synths. It looks like this picture here. It's more or less a bunch of modules with knobs that you kind of connect with cables, and it creates an analog video input output that kind of let you create video effects from scratch, more or less. You can kind of do it live. They've really been used, especially like if you've seen like MTV music videos from like the 90s. Got a lot of use there, but they've been used in movies. Some people still use them for live VJ sets. But yeah, this is kind of like the analog version of it. So the tool we'll be using today is something called Hydra. It's created by Olivia Jack, and she kind of modeled it after the idea of these cables that you're plugging into, adjusting parameters, and putting them out. Who here, raise your hand if you have at least some coding experience. Okay, cool. So we'll go over this a little bit, but this is kind of right here is kind of what it looks like. This little first part, and we'll dive into this a little bit more on the next screen, but kind of like feeds into this part. These are parentheses here, so you can kind of chain together these this text. One module feeds into another. It has some settings, but so if you're familiar with kind of JavaScript. That's what this language is. It's kind of the language that runs in the browser. Makes it very accessible for people to get started with it. It's essentially an abstraction layer over OpenGL and GLSL, which are a fancy, very like industry standard way of rendering 3D graphics. But for this, we're not specifically doing anything 3D. We're essentially creating shaders, which if you stick around, there's a shader workshop later in the day that'll be much more advanced for programmers. But this should hopefully be just enough that we can get you a little bit of JavaScript understanding so we can start playing around with this thing. So essentially, this kind of OSC, it's short for oscillator. That's describing the module. There's a bunch of set modules that you can kind of interact with. These parentheses are sort of grouping together the set of settings, these options that get passed in. they can be adjusted, and their position in the list represents what setting you're talking about, more or less. So the next thing is that you can kind of chain them together. So this dot is indicating that you're feeding from this module into this module, which applies some effect, some manipulation. In this case, it rotates the input pattern. The empty parentheses is important because even if you're not providing any specific settings, you still need to add it. Some other like kind of programming general things is there's this idea of variables that you can set. So in this case, var1 here gets replaced with 1 in this space. That'll maybe come to be important later, and we'll dive into a little bit more of a showcase type of thing. And then if people have laptops, you can definitely pull them out and play along. So next up we'll kind of go over these modules that I was talking about. I do have like some text, some slides here that are go into detail talking about it, but I think that probably the easiest way to work with it is to show you. So essentially we have a bunch of different modules. They're grouped into these categories. The sources are kind of your starting building blocks of modules. They're essentially patterns or textures and shapes. Geometry are kind of like geometric manipulations you can do to those shapes, those sources. Color applies like a color shift or color effect to it, and so there are a bunch of different versions of that. Blend is essentially how you combine different sources, or one of the ways to combine different sources. They have different kind of like mathematical effects. They can be kind of complicated. There is another category that I cut off here called modulation, which is very cool and kind of like the part of Hydra that is the most like a video synthesizer or even music synthesizer, but it's kind of hard to explain. So we'll get into that one to kind of show it off. So this is a slide just kind of going over these sources, which are important to understand, but I think it's easier if we maybe jump into some code. So let me open a new thing. So let's start from scratch. It might be easier if I grab a mic stand. Awesome. Everybody hear me still? Good in the back? Yes? Okay. All right. So let's just kind of go down the list. We've kind of already shown this OSC module. One of the important things is that in order to display it, is you need to go to call this .out. This is the URL that you can pull up on your laptop. It's hydra.ojac.xyz. So you pull that up. It'll start you off with a sketch that kind of shows off Hydra, but you can hit this little delete button to start from scratch. And so to run this entire program, you hit Control-Shift-Enter. You should see something like this. Yeah, let me tab it over. Is that better? Okay. Yeah, and essentially with this pattern is really important. in building Hydra things, because essentially what it is it's a kind of like vertically stretched sine wave. And so you can kind of see this like gradient effect where it's like more and less. And so we can play around with the parameters here. So this first parameter is frequency. It's sort of like the number of sine waves that fit on the screen. This second one is offset. Yeah. And it's more or less the speed at which they go. This third one is sync, which is kind of a strange one, a little bit hard to explain, but they're essentially, what is making this black and white is the fact that all of the sine waves are synced up. So if you kind of change the sync of them, it'll give you different colors. So if we run this, we get this kind of like changing color effect. And that's mostly because the frequency was low, so if we increase it, we kind of get this look. We can slow it down a little bit more smooth. And then you can play around with this parameter. I personally like, I tend to do 1, 2, or 3, but you get all sorts of just kind of like rainbow effects. I really like the kind of higher numbers. They get kind of like a nice smoother effect, but you kind of find the spaces that you like. Is there a question? Oh yeah, the great question. So the question is there Wi-Fi? And the Wi-Fi is the cell Wi-Fi, and the password is kittycat. All lowercase, no spaces. Okay. Yeah, so I'll give people time to connect to that and pull up Hydra and get to where we're at. I didn't really think about that. Okay. So another thing that might be worth pulling up is whenever you first open up Hydra, it gives you this little page that kind of explains what's going on. You scroll down here, and there's this list of links. Probably one of the most useful one is this list of Hydra functions, and that is essentially just, you could also go to this link /API. But it essentially lists all the functions we had before, including some other ones that I haven't talked about. But it's nice because you can click on them and it gives you kind of an example of what it looks like. And then just kind of different things you can do with it. This is kind of advanced function syntax, so if you don't know JavaScript, don't worry about that too much. But if you do, maybe play around with it. Yeah, so this is OSC. One of the other ones that we should probably talk about is noise. So yeah, that is a pretty cool effect. It's just kind of visual noise, simplex noise, if you're familiar with it. I think, but so it has kind of like a couple parameters you can play with too. The 10 is the default for the first one, which is scale. And so if you scale out a lot, it kind of looks like slow-moving TV static. But if you zoom in like this, it kind of gives you like this little kind of ghost wispy effect. There's also speed, which can be fun to play with, especially if you're trying to make some flashy graphics. Gonna go with some music. Then that's really it. Yeah, it calls it offset here, but it really more represents the speed that it plays around with. So we can move on to, there are other things like shape, which is a pretty important one. So default is this triangle. First is the number of sides. So you can get essentially any, I guess, platonic shape. And the second parameter is the size, so you can make it a lot bigger or a lot smaller. The values kind of range from 0 to 1. The next parameter is smoothing, so if we make this a little bigger, this will be a bit more clear. If you see here, it's not perfectly like a cut line. It's kind of like anti-aliased, I guess. But we can make it like really smooth, and it gets like this fade effect, a little less pronounced. That could be really cool for some of the kind of layering things that we'll get to in a little bit. But if you want it to be like a nice crisp thing, you can set this to a really low number. But you'll notice you get kind of like these pixelation with some of those shapes. But it looks really good for a square if you don't have any diagonals. You can also get like a circle by making it significantly high number, which also looks pretty bad unless you have the smoothing enabled. Yeah, super useful function. Gradient. This one's pretty useful too. I personally don't use it too much, but you can definitely do a lot of things, especially when you start layering things and using it as an input to other functions. So that's essentially just creates a gradient where each corner is one color, and then for every pixel it kind of fades between those colors, just interpolates. The pattern here is, the first parameter here is speed, which doesn't really make sense. It's really more of color, but yeah, it's worth playing with. You kind of get this fade between two things if you get it fast enough. Yeah, typically you're going to shift this around with some of the other manipulator parameters. So we'll go Voronoi is pretty cool. This is an interesting effect. It's sort of like a crystalline structure. It can also look a little bit like cells, but essentially the center of each cell is, I might be wrong on this, but the center of each cell is equidistant from all the dividing lines. And so that's kind of like a distribution that you get that creates this effect, and it has different gradients, and it essentially like noise powering kind of the color of it. Really similar to noise in that you have scale as the first parameter, so you can kind of zoom out a little bit. I believe same deal, its speed is second. Let's pull up, what's the last one? Blending. Don't think I've ever really used that, but yeah, so that kind of adjusts the these like points. If we set it significantly low, it gets more of a two-dimensional effect, gets rid of the gradient, or really high, it kind of turns into these dots, which are cool. Then there's solid, which is just a solid color, which can definitely be very useful if you're going for a specific thing. The parameters are red, green, and blue. So you can be red, and then it's just essentially kind of physics class of combining them. So like get some cyan with blue and green, or you can get yellow with red and green. So that's definitely a good one. So we start to get into the more fun things. Once we're here, you can start playing around with especially like OSC. So we'll get back to that and slow it down a little bit. So we can rotate things, and that'll rotate at a specific amount. The defaults are, I think, a 45-degree angle. It's in radians, so we can do like math.pi should, I guess, there should be, that's 45. no, 90 degrees. So math.pi is 90-degree angle. Default is math.pi divided by 4. Yeah, it's really more, I think the kind of the whole aesthetic behind this tool is it's built for live coding, so it's more about feeling it out a lot of the times than actually trying to build something specific. So yeah, that's rotate. You can also, the second parameter is speed, which is default to 0, but you can let it rotate over time as well. Scale, definitely useful. Essentially just zooms in or zooms out based on some of the parameters. Not going to be super clear on some of these, so maybe shape would be a good one to do. Right, so we have a shape of a specific size. Just to show this. Scale will make it bigger or smaller based on this number. Definitely comes in handy for other things. So pixelate pixelates things. In this case, it's applied to noise. Definitely a fun one to play around with. Repeat is also really good for when you're working with a shape. You can have it repeated across the screen. Probably, so you can also do this just for X and just for Y. So they get stacked differently. The kaleidoscope function is maybe one of the hardest to explain, but definitely one of the coolest effects. Here it's applied to this OSC, and you get kaleidoscope 50 is kind of big. So let's pull this over and play around with it. So we have this negative is indicating that it's actually going in the opposite direction. That's what's giving it this outward effect. If we give it the other way, it'll go inward. 50 is kind of a lot, but this kind of highlights what this is actually doing. It's essentially creating a kaleidoscope of 6 sides that is bending the coordinate space of this function. Kind of advanced stuff, but you don't really need to know how it works to play around with it. You can get some really cool effects. So the color stuff, definitely important, but I'm gonna skip over it for now because we can have a lot of fun with the other stuff. So I'm gonna start with sub because that's one of my favorites. So here they're subtracting 2 different oscillators, and it's giving this kind of like different effect over time. I really like to subtract noise from noise. The noise also looks really good in the kaleidoscope. That kaleidoscope is one of my most used functions for sure. So we have noise. We can maybe make it a little bit bigger. Yeah, this is good. And then we can subtract maybe some smaller noise. And essentially this is taking like these 2 separate noise functions and subtracting the values per pixel. That might not be super clear, but it essentially, if we do it a couple times, it can get a little bit more interesting than just the default noise, because then you kind of get different effects in different places. It gives it more like visual variety. Yeah, so that's a lot of fun to play with. Diff too, and the difference between diff and sub is not super clear. I don't know that I can fully explain it in a way that will make sense, but I think the big thing is like subtracting. It treats kind of 0 values or black differently. So you get kind of this separate effect here, so that they're more consistently the white color, and then you get like sort of black lines. So it's kind of a thing where it's best to build intuition with it, just play around with it. Layer is a good one, and it does not work very well with noise, because it essentially uses luma values and transparency, and noise doesn't play well with that. There's some tricks you can do to make it play well, but for demonstration purposes, we're going to just kind of show off the function with shapes. So we can, make this maybe what would look good? A square on top of typo again. Is the square too big? This is I think layer is one of the more hard to kind of grasp functions, just because of the way that it works. When it works, it's very cool. It has very interesting effects, and it's like the stuff that's here doesn't really demonstrate it. This is probably a good one, which is maybe overly complicated, but it works really well with OSC. And here you can see that they're calling this luma function, which I didn't touch on, but that's probably why, because some of these sources just don't have transparency until you toss a luma on it, which can be a little bit confusing what it does, especially if you're not coming from a like web graphics background. But if we take it off, maybe it, so then it just straight up doesn't do anything, right? We just see this. But so this is taking the kind of close to black values and turning them into transparency. And so we see the underlying 30 size oscillator. So that's layer, pretty useful. Blend is a little bit more user-friendly. Here they're doing kind of what I was doing with layer to start. Let's simplify this. So this array, and this is something I haven't touched on yet, but if you pass in these square brackets in this list, it'll essentially cycle through these values. So you can change these parameters over time in a simple declarative way. So we'll do just 5. So essentially we're taking this shape, scaling it for some reason, which we don't really need to do. And we can blend it with another shape. 0.5 is actually the default parameter, but this parameter is essentially like which controls which source you're pulling from more. So if we put it really low, then we see more of the triangle. If we put it high-ish, we see more of the square, but you can kind of still see the triangle shape here. So it just kind of blends them instead of worrying too much about stacking them like layer, and you don't need to worry about luminosity or transparency. Mask is good too. Which one is good example? This looks pretty cool, right? Maybe a little bit, starting to get into a little bit more advanced territory in terms of the colors and shapes that you can do. We have this underlying default oscillator, and we're layering it on top of this other oscillator and masking it with a shape. So mask is essentially saying for the white values of this source that we're passing in, only select only select the white values from the initial source, right? So this oscillator is the nice colorful one, and then the shape is white in this box, and so we're taking only that section. And mask does an interesting thing where it also does this luminosity trick and applies transparency, and that's why it works with layer. So yeah, if you're going to try to play around with layer, it's usually useful to apply some mask or call that luma function. Yeah, and so we can maybe jump into something, these modulate functions, which are really cool but also very advanced. But before that, I want to just stop, ask if anyone has any questions. At some point, it might be cool to have me bounce around and take a look at what people have made or play around with it, but we'll get into that in a bit. Yes. So, yeah, I'll repeat it for the stream. So the question was, for the square brackets for sequencing, can you control the time? And so if you scroll down to the bottom, this array section are essentially different things that you can do to those sequences. So if, let's say we want this to like go through some different shapes, right? And that will change. So this square bracket at the very end, you do this dot fast, like we did with the kind of other chaining type of things. And so you can give it a multiplier, so you can make it twice as fast, which maybe doesn't show up, but we can make it 10 times as fast, which is more clear. You can also slow it down by giving it a smaller parameter. And there's some other ones that are super useful, like smooth, kind of makes it move between the parameters continuously. Ease lets you play around with, like, if you're familiar with like easing functions, those kind of things. Yeah, I'll let people kind of dig into that stuff on their own. They're useful, but not super necessary to understanding this tool. I think Jessica. Oh, okay, great. Yeah. That is a great question. Yeah, okay, yeah. Yeah, I don't know the inner workings of this function. I'm surprised that it doesn't handle it. But I believe, this is JavaScript, so if you're oh, there's a bunch of exceptions in the console. That breaks it. Okay. I'm maybe go fix that on the thing, because now it's like I have to reload my tab. Yeah, so don't give it a negative parameter for now. That's probably a bug. That's not something you want to happen. So this is still JavaScript, so like not super familiar, but maybe, yeah, so this is reverse. That returns. So yeah, you could maybe, if you wanted to go backwards, you could just call dot reverse on it. Yeah. So the question was that if we give it a negative parameter, will it go backwards? And the answer is that it seems like there's a bug in Hydra that crashes the editor. But if you want to reverse it to go backwards, you can call dot reverse on it. That seems like maybe it worked. Maybe it didn't. Yeah, it's just going very slow. Okay. Any other questions? Yes? Oh yeah, that's a good question. Some of the examples do out 0. This is a buffer in our kind of world. So there are different like output buffers that you can put out to. The one that gets rendered by default is O0. So if you get it with nothing, it's like that. You're telling it, hey, put this on the screen. You can also I think they're numbered up to 9 or something, but you can output to O2, and that should then be, you can render it here, but it's a little bit advanced, but you can essentially get different buffers and then read from different buffers and kind of link together things and do a lot more complex stuff when you're building things out. It's especially useful for like feedback, so you can actually take the output from one buffer and input it to other things using the source function. We might play around with that if we get through the modulation section, because that is kind of where Hydra shines, is the idea of feedback. You can get really advanced and beautiful things with feedback. Cool. I think there is another one. Yep. Yes. There is a trick. So the question was that right now we have this kind of like, it should be a square, but it's kind of stretched out. It makes it look like a rectangle. There is a trick, and I don't know that this is the best way to do it. But so if you wanted it to be, let's go 4. You can do, what is it? Scale 1, and then it's like 1/16. No, 1/9. Essentially, you want to shift it by your screen coordinates. So my screen is maybe not 16 by 9, but 9/16. Yeah, okay. So that you essentially want to do it the inverse of your screen ratio. So I don't think I really touched on this, but scale has, the first parameter of scale is just kind of like the zoom factor, more or less. It scales both axes, but the second and third parameter are X and Y. So you can actually scale this down to like half, right? And then it squishes it in. And you can do the same for the other direction. And so the trick is you squish it in that direction at your resolution, and that should get you a nice clean square. Good question. Yeah, so the question is, what's the coordinate system? And I think that is kind of it's weird. So it should be more or less 0 to the right. 0 is the center. 1 is the rightmost corner. I believe the top one is 1, and then -1, -1. But it doesn't really come up that much in there's a function I haven't talked about, which is probably definitely something I should have touched on, but there's a scroll function, and it kind of offsets things, and that's where it comes up the most. So let's see. So if we scroll 1, I guess it goes all the way back around. 0.5 is like right there. So yeah, the idea of a coordinate system is it's very loose in this setup. But one of the fun things with this is you can just give it a non-zero second parameter, and it'll move over time. Then you don't need a coordinate system, and it also just loops back around. There's also scroll Y, which will go the up and down direction. Yeah, absolutely. So you would just, the question was, can we have two shapes? So you just do another layer and maybe make it go X and Y. And yeah, so then you have two. Yeah, it's a little bit advanced, so maybe I'll get into it later. But yeah, essentially you can use for loops. You can use let and just chain it, make calls, and reassign it, and then output it. Yeah. Any more questions? Cool. Let's play with modulate. Let's clear this out. So we have maybe a shape. Maybe we need to render. Yeah. So if you tell it to render another buffer, then you might need to tell it to render the default one. So let's get just a basic shape, and there's this modulate function, and it essentially takes in another source. So this is another way of combining sources, but it does something a little bit different. And the easiest way to explain that is maybe to show it to you. And so here we're applying this oscillate function, which I said before is the sine wave, this vertical sine wave. And so we're passing it into this modulate function. And what this is doing is it's essentially shifting the coordinate system of the first shape. You can think of it as just like pushing the pixels around. And you end up with this wave function where you can kind of see the original shape, but it's being pushed around by the positive white values. And this might not be super clear, but essentially it's saying it's taking the red value and the green value and pushing the pixels for that amount in that direction. And so this input is essentially just a way of chaining these things. The second parameter here is the default 0.1. This is kind of the amount that it does it. So if you do it less, you get this kind of just a little wiggle effect. Or if you do it more, you get something significant and kind of chaotic and hard to understand. And so the idea behind modulate is you're taking these color values and using it as a parameter to adjust this kind of system. Each one of these other modulate functions essentially works as its kind of counterpart. You can see modulate, pixelate, and pixelate, and essentially that is using the input texture to control that function per pixel. And I'll show you, maybe this would be a fun one. Modulate rotate. So it's essentially kind of rotating the pixels per this oscillator. We maybe give it like the oscillator kind of a circle. You can kind of see where it's like kind of rotating the edges around. It might be more clear if we just look at this. So this is what that oscillator is doing, and for each of those kind of white sections, it's applying a rotation function to the pixels that line up with that, which is not super intuitive, but yeah, you build up a intuition for it, and you can start to play around with it and build cool things with it. I personally like modulate scale a lot, which applies the scale function. And so it's sort of like sourcing into, like selecting pixels, pixel values from the first thing. So that's why you get like this kind of pushed effect. It's just nudging things around. This might be a little bit more clear. For modulate scale to pass in noise, maybe do a little bit less. So we get like this kind of like wavy noise function is getting a little bit pulled. Modulate scale and modulate are pretty similar. Yeah, so you can see they're not too different here, but scale is a little bit more smooth typically. Modulate pixelate's a lot of fun. So we can. This one is actually kind of interesting because it doesn't work well with noise either. Yeah, and it's not always super clear what's going on with pixelate. So we didn't really touch that much on pixelate itself. Yeah, so it's not great to look at with shape. So yeah, it's essentially taking kind of like the average of the sections and then rendering it into this pixelated effect. And so modulate pixelate can be a little bit unintuitive in that aspect. This is kind of a fun sketch, so let's take a look at it. Right, so they are essentially taking this noise, modulate pixelate, and then you can see these sections that are getting more pixelated for when this noise value is higher. It's pixelated to these 8x8 squares. Yeah, and so I guess the first parameter into this is the multiple, and then you have offset. So you need to give it, I guess, a more significant value to have it apply, but definitely a lot of fun to play with if you can find kind of the sweet spot. And that's what I think the gist to take away from a lot of this is that a lot of these functions have ranges that they're the happiest in, or that might be the most appealing to you, and finding those and playing with it and getting it, building up an intuition for it is definitely important. So I think one of the last things I kind of want to touch on just very quickly is the idea of using the camera. So we talked a little bit about buffers, and those are useful, but I think the kind of more interesting thing, not more interesting, but another interesting thing is init cam, like this source. It's like similar to buffer, but it's a source. It's an input rather than an output. S0. You can call this init cam function on it, and then whenever you call source, so this is essentially what takes a source and turns it into a source, is the source function. Yeah, naming things in programming is hard. But yeah, so this src function will essentially read from this source, put it out, and so here you can see my webcam is now enabled. And what's really fun about that is you can do all of these effects on it, like modulate, noise, and then you get kind of a weird noisy effect here. Yeah. Almost fluid, OSC. Yeah, and you can do anything in this whole set to your webcam. You can also do the same thing with images, videos, streams. You can read from your screen. It's essentially anything the browser can do. You can throw it at it. Definitely worth playing with. Source is kind of cool too. This src source is cool too because you can read from the output buffer, right? And this is probably not clear, but yeah, so it's essentially taking the previous frame's value and then reading it in and putting it out to that frame. So you get this loop that is currently doing nothing. But if we do something like mask it with this like shape, and then do something like invert it, which will take the value and repeatedly like reverse its value. I think that kind of idea of invert is pretty common, but then like scaling it down gets a pretty cool effect. So essentially you're taking this shape, inverting from the previous buffer, previous frame, inverting it, scaling it down a little bit, putting it out, and then doing that again in this feedback loop. And this creates very unpredictable, chaotic effects, but it's kind of like Hydra's wheelhouse. So once you've kind of mastered all of these basic building blocks, you can start to apply them to this very like powerful feedback system. So we can do like scroll X, and that'll get this like fun like loopy thing. It's like a whole different dimension here. I like to throw in some rotate. You get, this is where you start to get this kind of like fractal feedback type of effect. So yeah, that's just a little bit of a taste of kind of like more advanced things you can find. It's really an infinite scape. Hydra sort of provides you a set of building blocks that makes it really easy to get something cool on the screen really quickly. It's built for this idea of live coding, which is where we essentially create improvised visuals written in code, with the code shown as a performance to go along with music that is also written with code, also displayed, also improvised. And we call these events algo raves. We're having one tonight. It's going to be a lot of fun. Definitely come out. I think to close, I'll maybe come around, look at people's things, look at what everyone created. If you, I'll put this on the screen. If you send something that you create, you find something that looks really, really cool, if you send it to me, at my email address, we can have them displayed on these fireplace monitors during the Algo Rave event, and just kind of cycle through them, display them. So any last questions? can you hook up to audio? Yes. That's something I should probably touch on. It's a little bit more advanced, and just because I didn't want to have to explain the arrow function, but essentially Hydra provides you with this A variable. You basically call a.fft, which is kind of hard to explain, but it's a fast Fourier transform. So let's do a.show, and that will show up. So down here in this corner, you kind of see these buckets, and they're kind of reactive to the audio. And so we can choose one that is pretty active. The problem is that this is a function, or this audio thing is something that changes over time. So because of the way that JavaScript works, is you need to put this in front of it anytime you want to use this value. This is essentially an anonymous function. If you're familiar with JavaScript, and Hydra knows how to do this and use it to call it whenever it's doing its update function. But if you don't know what that means, then don't worry about it. Just remember to put it. And so now you can kind of see it's like, maybe not super obvious because of how chaotic this is, but it's reacting to my voice. Let's go back and do like this one here. Yeah, so that's a little bit more obvious, but yeah, that's how you make things audio reactive. And that, if you're doing like visuals at a live coding event, that's pretty important. It's a pretty useful tool, very powerful. You can do that a.show and then just kind of see which bucket is the more interesting or active, and throw it in your code somewhere that you think might look cool. Give it a cool and powerful effect. All right.